today's episode of The Great Math Adventure. I'm at Hartsfield-Jackson Airport, one of the busiest airports in the world. In this lesson, we're going to take a look at solving by square root. This is going to be an alternate method for solving quadratics when factoring might not be the easiest way. So we're going to take a look at this method, and let's go ahead and jump into the notes.
Alright, so as I mentioned in the intro, we're going to take a look at a different way to solve quadratics, and we're going to use this specifically for a certain case that we're going to get into. But before we get into that, I want you guys to remember back to Unit 1 when we were working with solving equations, just your regular equations like 3x plus 7 equals 12, equations like that. When you think about the strategies that we used to solve those, we were using inverse operations. Those were operations that undid each other. So, for example, addition and subtraction were inverse operations, and multiplication and division were inverse operations. One undid the other. We're still going to use inverse operations when we're solving quadratics. Now, the problem that we run into with quadratics is that isolating the x variable can be a little bit tougher, since we usually have more than one x value. We'll usually have an x term and an x squared term. So that complicates things a little bit. We did look in Lesson 5-3 about how we could factor. And the thing with that is, though, we only were able to factor if we were in intercept form or in standard form. There is actually going to be one very specific situation that solving quadratics by square roots is going to be a little bit easier and more straightforward method, and that's going to be when we are missing that b, when that b value is equal to 0 and we don't have the middle term. We have the ax squared and we have the c, but we do not have the b term. We did look at how to factor a problem like this in our last lesson, but this one is going to be a little bit more straightforward and probably a little bit quicker to use when you are dealing with a quadratic that is missing its b term. So one thing that we need to remember is that the inverse operation of squaring a number is taking the square root. Those are going to undo each other. Just like multiplication and division undo each other, the squared and the square root are going to undo each other. So if we look at some examples, if we take the square root of x squared, that is going to give us plus or minus x. Now, a little bit about why we have that plus or minus sign in front of it. What that means is we actually have two possible answers. Because if we think about what it means to take the square root, that means that we are looking at how we would figure out what two numbers multiply together to give that. Now, in this situation, we could multiply x times x, and that would give us x squared. However, if we took negative x and multiplied it by itself, that would also give us x squared. So that is why we put that plus or minus symbol in front whenever we take the square root. Now, we did put a little reminder here for you guys. Remember that every square root, with the exception of the square root of 0, will have two answers, and you will have both a positive and a negative root. So whenever you are taking the square root, you're always going to need that plus and minus sign in front of it unless your answer is going to be 0. Because remember, 0 is neither positive nor negative. So we look at a couple other examples. The square root of 4 would give us plus or minus 2. And taking the square root of 4x squared would give us plus or minus 2x. So let's go ahead and look at some simple examples. In example 1, we are given x squared equals 49. Notice that we have the x squared all by itself. So all we are going to do is undo that by taking the square root. So I take the square root of x squared, and those are going to cancel out and just give me an x. And then I'm going to take the square root on the other side, and that's going to give me plus or minus 7. I put that plus or minus 7 there because I could do 7 times 7 and get 49, or I could do negative 7 times negative 7 equals 49. So that gives us our two answers to this problem, or our two solutions, or our two roots, whatever you are using as your terminology. Let's go ahead and do one more. We are going to take x squared equals 50. We are going to take the square root of both sides. So that's going to cancel out our squared term, and we're going to be left with x. And then we get the square root of 50. Now, just like in Unit 4 when we were working with radicals, you will need to take a look at whether these answers need to be simplified or not. So I am going to make my factor tree for 50. Now, a lot of you guys have already noticed as we're doing these, we've come up with 50 quite a few times, that this is 25 times 2, with 25 being that perfect square. So the square root of 25 is going to be 5, so we will pull that out front, and we're left with just the 2 underneath. And remember, we still have to put that plus or minus sign. Now, that's as simple as we can go. Usually, we'll go ahead and leave this as a radical in its simplest form, but when we get into some application problems later on, then you will be asked to change it to a decimal. We're not going to bother with the decimal on just a raw problem like this. We'll go ahead and leave it as a simplified radical. Alright, you guys have 2 U-Try problems to attempt. Go ahead and give those a shot and come back and see us in video 2. See you then.